let f is defined from A to R. So like here, A is a subset or equals to set of real numbers. Clear? The function f is said to be continuous at x is equals to A. In bracket, I am writing here. Yes, please. A belongs to capital A, that means domain of the function. If, right? So the definition of continuity is, yes, please. Limit should exist at the given point and the limit value must be equals to the function value f of A, right? So like we can say the necessary condition for the function is to be continuous. First of all, it should be defined at the given point. If it is not defined, definitely it is not continuous, right? The necessary and the sufficient condition is limit should exist and the limit value must be equals to the function value. We can elaborate this limit existing thing. Maybe if the function is having two different definitions in the neighborhood of A. In right neighborhood of A, the definition is different. In left neighborhood, the definition is different. In that case, we can say limit x approaches A minus f of x should be equals to limit x approaches A plus f of x. This must be equals to f of A, right? Left hand limit must be equals to right hand limit, that must be equals to function value at A, right? Yes, please. So this definition again we can write in a different way. Yes, please. This is another way of writing limit, right? So this is the definition of continuity in simple words. There is no breaks in the graph of the function. Clear? I hope everybody understood. Please do remember the point where we are checking continuity of a function, that must be interior point of the domain. It may be the end point, but that must be an interior point. Clear? So this is about continuity at a point. At a given point, x is equals to a. Clear? Understood the definition? Right? Can I scroll up? Mhm. Clear? So using this definition, maybe how they ask the problems in JE. Yes. No, like what we are actually doing is like by writing a minus h, anyway you are left side of a. You are subtracting something from a, right? So you are on left side, you are subtracting something from a, you are on right side, right? It is not necessary to write 0 minus or 0 plus in that case. Anything else? Understood this one? This is about continuity at a given point, right? Point must be an interior point. Can I scroll up? right? So like maybe we can extend this one. We can see continuity at in a interval, closed interval, right? See, in a closed interval, if you notice, like for example, some closed interval, if we are taking closed interval A to B, we are considering here, right? So, like if you notice that the function is defined from A to B at the point A, if we are trying to find the definition of function in the left neighborhood of A, the function does not exist in the left neighborhood of A. Am I clear? If you are writing like x approaches A minus f of x, there does not have any value. Function is not defined right left side of A. Clear? Same thing we can apply for B as well. Function is not defined in the right side of B. At A, we should not check the left hand limit. At B, we should not check the right hand limit. Am I clear? Yes. At the end points, only one direction limit we need to check depending upon what endpoint it is. Right? So let us write this one here. The function f is said to be continuous in closed bracket A to B if the function is continuous in the open bracket A to B. What does this mean? The function is continuous at each and every point in the interval, open interval A to B. Clear? Understood? Like at each and every point, if the function is continuous in the open interval, that is first thing. And the second thing is like f is right continuous at A. What is right continuous at A mean? Right continuous at A means limit x approaches A plus f of x must be equals to f of A. This is right continuous at A. The last and final thing, f is left continuous at x is equals to b. We can say limit x approaches b minus f of x must be equals to f of b. Right hand limit exists and right hand limit is equals to function value implies that is right continuous. Left hand limit exists and left hand limit equals to function value implies it is left continuous. Am I clear in this? Any doubt in this? Right, like in a closed interval to check the continuity of any function, first thing is like function must and should be continuous at each and every point in the open interval A to B. Clear? See, like if you want to write this one mathematically, you take an interior point C belongs to A to B and you prove that for all C belongs to A to B, f of x is continuous, then we will say it is continuous in open interval A to B. Clear? Next thing you need to do here is check the right continuity at the A because in the left neighborhood function is not given in the problem. Clear? check the right continuity, and then at B check the left continuity, because like in the right neighborhood here, function is not defined in the problem. Am I clear? Any doubt in this? Like first one is continuity at a point, second is continuity in a interval. Understood? Any doubt in this? Anybody? Please do understand this is basic thing of continuity. Clear? Can I scroll up? Right now, normally they will say in the problems a function is continuous. They didn't define anything. We can take that one as domain. Clear? Function is continuous in the domain of the function. If a function is continuous in the domain, what does that mean? You take some point, an arbitrary point C belongs to domain. If the function is continuous at C, right, if that is true for all C belongs to domain, then the function is said to be continuous function. Clear? Understood? Right? Maybe the domain can be added or extended till real numbers if the domain is real numbers. Clear? Can I scroll up? Can I scroll up? So maybe these 2 points we will add here. Right? This is about continuity in a domain, continuity in real numbers. Clear? So like next we should learn about continuity of some standard functions. Right? So standard functions, I mean in functions we have seen, no, starting from polynomial till logarithmic and exponential, everything we should write. Maybe in one line I can say those all things. Understood this? Can I scroll up? So starting with polynomial function, right? All polynomial functions are continuous in R. All polynomial functions are continuous for every real number. Clear? So next, all trigonometric and inverse trigonometric functions are continuous in their domains. As I said, the continuity point or the point where we are checking continuity must be an interior point, right? For example, if I am taking tan x, it is not defined at odd multiples of pi by 2. So by default, tan is discontinuous at x is equals to pi by 2. Clear? Understood? Right? Function is not defined means by default it must be discontinuous. Continuity point must be interior point of the domain, but discontinuity point may or may not be interior point of the domain. Am I clear? So what will be the next? I think logarithmic and exponential, same statement you can write. Logarithmic and exponential functions are continuous in their domain. Please don't think log of some polynomial will be continuous for all values in the domain, right? So like if you are having any value outside of the domain, it is discontinuous. Am I clear? Write that one also. What else we left here? Polynomial, trigonometric, inverse trigonometric, exponential, logarithmic. Modulus is continuous in R. Greatest integer and least integer is discontinuous at every integer. Fractional part also discontinuous at every integer. Clear? Signum is discontinuous at 0. That we will add. Right? Greatest integer, least integer, fractional part function are continuous for all real numbers excluding integers. Am I clear? Any doubts in this? It is one is floor and another is ceiling. Like we can say least integer na greater than or less than or equals we will say. For example, in GIF 1.5 is 1. In LIF 1.5 is 2. Okay. Opposite it works. Integer na same integer it gives. Understood? Any doubts in this? This is basic things. So if you want, you can add about signum, greatest integer, least integer, fractional part. I can say that greatest integer and fractional part are right continuous at every integer. Least integer function is left continuous at every integer. Clear? So maybe let us add this. Yes, please. Then let us do some problems on continuity. Any doubts in this? You guys understood what is like how it is right continuous, how it is left continuous, right? Didn't understand. Somebody shaking head in different direction. For example, if we are taking a greatest integer function at some integer, maybe at x is equals to 1, we can take. Please stay silent. So like here I can write limit x approaches 1 plus in the right neighborhood of 1, greatest integer of x must be like this is how I do when there is greatest integer. Like if I am in right neighborhood, I am going to substitute 1.1 in the x and I am going to find how much is the value. Am I clear? That is for greatest integer, like that I will do. So like if I do, I'll be having greatest integer of 1.1 here, that is 1. Clear? So like now, maybe same thing if I'm doing limit x approaches 1 minus greatest integer of x. What I'm going to use here is like in left neighborhood of 1, maybe 0.9 or something I will use. And then greatest integer value of 0.9 will be equals to 0. And then the function value will be equals to 1 here. See here limit x approaches 1 minus f of x is not equals to limit x approaches 1 plus f of x. Therefore, limit of the function does not exist. If limit does not exist, function cannot be continuous. Clear? But notice that at 1 right hand side of the 1, I can write here limit x approaches 1 plus f of x will be equals to f of 1. This is the reason why we are saying greatest integer function is right continuous at every integer. You can see in the graph there will be circle at every integer, right? So like now if you are seeing the left hand side of the integer, there is a jump, right? At in between 0 to 1, right? At 1 this one will be empty and the above one we will fill. Clear? So there is a clear jump at 1. In the right side it is continuous, but in the left side it is not continuous. Clear? Any other doubts? So this is about the basic definition. I can say the continuity concepts is done. Now maybe types of discontinuity is there and problems is there. This much only we have. Maybe one table. If time allows today I'll give combination of continuity. So I can see maybe let us start with some easy problem, page 57, problem 45. If you know the limits, you can solve this problem. If you don't know the limits, please wait. I'm going to teach how to do this problem using limits. You already solved this you can solve some other problem from maths. 45. See, like in continuity and differentiability, when the function is non-uniform function, please do check the continuity and differentiability at the points where function is changing the definition. For example, in the 45, they have given f maps R to R be a function defined as f of x. Definition is different in the left neighborhood of 0. Definition is different in the right neighborhood of 0. So 0 is the point of doubt. At 0, we need to check the continuity. Clear? So like now, what is given in the problem? If function is continuous at x equals to 0, then the value of a plus b. If the function is continuous, limit x approaches 0, f of x must be equals to f of 0. Since there are two different definitions in two neighborhoods of 0, left hand limit and right hand limit must be equals, and that should be equals to f of 0. Again, like these all three must be finite values. It is not like this is infinity, that is also infinity, the last one also infinity. It is continuous. It may be infinity, but like it is different type of infinity. Finite value only we'll consider as defined. Can we start this? Can we start this? Right? So I am seeing this. It is given function is continuous. After seeing the continuous thing, what I wrote here, I wrote limit x approaches 0, f of x is equals to f of 0. I have noticed it has two definitions. So limit x approaches 0 minus f of x is equals to limit x approaches 0 plus f of x must be equals to f of 0. Now checking the function value at 0 is b they have given. Finding the left hand limit. For left hand limit, limit x approaches 0 minus f of x must be equals limit x approaches 0 minus sine a plus 1 into x plus sine 2x divided by 2x. So if anybody don't know anything about the limits, let me write one small recall here. There in 11th grade, it will be there that says limit x approaches 0, sine of a into x divided by x is equals to a. Clear? So using this recall, we are finding this limit value. If you don't know about the properties, let me tell you, limit is distributive over addition, subtraction, multiplication, division. Limit you can take wherever you want. So I am making this one into two parts. You are from JE only, no? Okay, no problem. Sorry for asking. I am seeing you first time if I am not wrong. So limit x approaches 0 minus, we have sine a plus 1 into x divided by 2 into x plus limit x approaches 0 minus sine 2x divided by 2x. So forgot about the 2. 2 is like constant as we do in differentiation and integration. 2 we can take out of limit. Then notice the remaining part, right? The first limit we are going to get is 1 by 2 into a plus 1. The second limit we are going to get is 1 by 2 into 2 we will get. Like any doubts in this, anybody? Yes, please. Any doubts in this, anybody? No doubts, right? So like I can say this will be equals to a by 2 plus 3 by 2. We have, maybe we can say this will be okay in this way, a plus 3 by 2. This is the left hand limit we have calculated. This left hand limit must be equals to b. So LHL is equals to b. This implies a plus 3 is equals to 2b, a minus 2b is equals to 3. I hope I'm clear till the step, right? So next, right hand limit. For right hand limit, if you notice, right? So what we can do, I think, like I can say, limit x approaches 0 plus f of x will be equals to limit x approaches 0 plus the given thing is square root of x plus b into x cube minus root x divided by in denominator we have b into x to the power 5 by 2. Some doubt, dear? Oh, yep. Okay. Thank you. Anything else? Okay. So this is what I have. I think before I forgot to mention in limits, we should make this one as a habit. Next to the limit, we should write what indeterminate form it is. How to get that? By substituting a zero in the given. Right? If I put zero, the numerator is zero, the denominator is also zero. It is zero divided by zero indeterminate form of a limit. This limit I can solve using L hospital rule or L hospital rule. I can also solve by rationalizing or factorizing or anything like that. Am I clear? So like I can apply L hospital rule. If you don't know what is L hospital rule, let me tell you in L hospital rule you can differentiate the numerator and denominator separately as many times as you want to remove the indeterminate form. Clear? So like maybe in the first problem I'm not going to use the L hospital rule, I'm going to use the rationalization, right? In rationalization technique, I'm going to multiply and divide with the same thing, but like what change? It will be plus in between, right? So this will be equals to limit x approaches 0 plus, I hope you understand. Once we multiply and divide with the rationalizing factor in the numerator, if you notice, you have a plus b into a minus b, that is a square minus b square. In a square minus b square, square and square root will be cancelled, and we should write here x plus b into x cube minus x divided by in denominator b into x to the power 5 by 2 square root of x plus b into x cube plus a root x we have. I hope I am clear in this step, right? Next, plus x minus x got cancelled. If you are thinking sardine wrote modulus, uh, we are on right side of 0. In right side of 0, mod x is same as x, and the function x plus b into x cube must be positive, then only the limit value exists, or else it won't. Am I clear? Right? So next, maybe we can say this is limit x approaches 0 plus we have b into x cube divided by b into x to the power 5 by 2. In denominator, we have square root of x plus b into x cube plus root x. Notice that in denominator I have x to the power 5 by 2. I can take one x to the power 1 by 2. Both put together you get x cube and x cube, b and b will get cancelled. Now the remaining is limit x approaches 0 plus 1 divided by a root of 1 plus b into x square plus 1 we have. Now the moment I substitute 0 in this, how much we have? 1 by 2 we have. As they have mentioned, it is continuous. This implies what we can write. Right hand limit should be equals to f of 0. So b value is 1 by 2. Using this b value, how much we will get in a? So a is how much? Minus 2, minus 2 I guess. So then what we need? One moment, one moment. A plus B is minus 3 by 2, second option. Correct? So like, now tell me dear, Sri Vishnuvardhana. Where? Which, which one? I am taking root x common. This root x came out. And here also there is one root x I am taking out. So x I should take out inside square root. It is 1 plus b into x square. If I put x0, right? Anything else? Anything else? Okay, you can copy from here. Any doubts? Anybody? Thank you. Can I scroll this one up? Let's solve this much only easy problems. Page 59, problem 53. What dear Gautaman, what is happening there? Huh? Where? Before you came on. Where is Tarun Chris? Absent, ah? Why? Huh? What he said? Scrolling up here as well. Is this okay? My dear students, let me tell you, like, don't worry much about writing or like, uh, don't think much about which you missed. Take notes from your friend, take photo, or else I'll upload this one by the end of the day in Teams. Right? So leave that one, concentrate on this. Try to understand how we are solving the problems. Can I scroll completely up? Anybody writing this? Right, please. So then 53, I think most of you, what you should know here is, if I remember correctly, 1 for infinity or something you should know how to find. If you know that, you are done. If I'm right, yes. How much is cot phi? Cot phi? Ah, ah. Done. Fully done. Right. So next is page number 59, problem 53. So in this problem, maybe a small recall before solving this. See if we have something like this. 1 for infinity indeterminate form. This one I'll call as e to the power L. We will get the limit value. The L here stands for limit x approaches a g of x into f of x minus 1. This is a rule. We should write the power in multiplication and we should subtract minus 1 from the base. This entire thing will be happening in e to the power exponent e. Clear? So now let us see the given problem. In the given problem, if you notice, as I said, the function is given, right? And it is continuous also they have mentioned, and some value we should calculate. For that, if we see the function is like at a point of doubt is pi by 2. So checking left hand limit, right hand limit at pi by 2. So like first of all, LHL is equals limit x approaches pi by 2 minus in the left neighborhood of pi by 2. The definition of function is 1 plus modulus of cos x whole power lambda divided by modulus of cos x we have. We all know as x is approaching pi by 2, cos will be equals to 0. This is 1 to the power infinity indeterminate form. So we are applying the formula. This must be equals to e to the power L, where L will be limit x approaches pi by 2 minus lambda divided by modulus of cos x into 1 plus modulus of cos x minus 1. So plus 1 minus 1 gone. Modulus of cos x, most like here in left neighborhood in quadrant 1, cos is positive. You can directly write cos x. Both in numerator and denominator it will get cancelled. L value is equals to lambda. Now the left hand limit will be equals to e to the power L. So that will be equals to e to the power lambda. Clear? Any doubt in this one to anybody? Please let me know. No doubt. So next is right hand limit. For right hand limit, we are taking limit x approaches pi by 2 plus in the right neighborhood of pi by 2. Function definition is e to the power cot 6x divided by cot 4x. Right? So now if you notice the limit we can take in exponent e power as well. You can write e power limit x approaches pi by 2 plus cot 6x by cot 4x. If we substitute x is equals to pi by 2 there, we are having cot pi, some pi divided by again cot, some different pi. We have infinity divided by infinity form of indeterminate here. Do everybody understood how I am identifying the indeterminate form here? No? You substitute pi by 2 in place of x. What you have? Cot 6 into pi by 2. That is cot 3 pi. Cot multiple of pi will be infinity. In denominator again substitute pi by 2. That is clear? Infinity divided by infinity. See, we can reduce this one and we can write this one as limit x approaches pi by 2 plus. Now this becomes like we know cot is 1 by tan e to the power tan 4x divided by tan 6x. Right? This everybody understood? I wrote reciprocal. Now if I put x is equals to pi by 2, what is happening? Notice tan into tan 4 into pi by 2, that is tan 2 pi. Tan 2 pi value is 0. In the same way, tan 3 pi also 0. 0 divided by 0 indeterminate form. Right? So let me do another recall. We should say limit x approaches a f of x is equals to 0 and limit x approaches a, tan f of x divided by f of x will be equals to, one moment, instead of this way, this will do, right? If you have x approaches 0, tan ax by x is equals to a. In limits also, if we want, we can take substitution. You can write 4x approaches and 6x approaches pi there. That means like we are, one moment, just give me a moment. Tan 4x by tan 6x. I think cannot use this thing over here because like there I'll multiply and divide. I am not allowed to do that. I am using L'Hopital rule. I am not finding anything else here. Multiplying and dividing 4x, I thought, but like 4x is not approaching 0 no when x approaching pi by 2. So I am not allowed to use that. Applying L'Hopital rule, this is limit x approaches pi by 2 plus, so like differentiating numerator and denominator separately, the derivative of tan 4x must be equals to 4 secant square 4x divided by 6 secant square 6x. I think here if I substitute pi by 2 now, I don't have indeterminate form. Secant square of 2 pi divided by secant square of 3 pi, we are going to get e to the power 4 by 6, that is e to the power 2 by 3. Everybody understood this one over here? So like now this is right hand limit e to the power 2 by 3. Now left hand limit must be equals right hand limit, that must be equals to function value. So e power lambda is equals e power 2 by 3 is equals mu we have. So we can say lambda is 2 by 3. What we should find now? We should find 9 lambda plus 6 times of ln of mu plus mu to the power 6 minus 6 into, sorry, minus e to the power 6 lambda. I think mu and e power lambda are equal. This two must be 0. 9 into 2 by 3 plus 6 into ln of e power 2 by 3. I'm having 10. What is given answer here? Anybody checked? Please do check once. What they have given there? Are we having 10 there? Or we should check again? 10 only. Oh, thank you. So like starting from here, if any doubts is there, please let me know. Down you have. So once more you want me to explain. See, like in the given problem, if you see the point of doubt is pi by 2, clear? right? We are checking, or we should equate it is continuous only they have given. So left hand limit at pi by 2 should be equals right hand limit at pi by 2. That should be equals f of pi by 2. F of pi by 2 is mu given. Now, in the process of calculating left hand limit, right? Whatever limit it is, first key thing is identify what indeterminate form it is. How can I identify? By directly substituting here. If I put pi by 2 there, 1 plus cos pi by 2 is 0. This base is 1. Now in power, lambda divided by cos pi by 2, like some finite value divided by 0 must be infinity. Whether it is positive infinity or negative infinity doesn't matter. 1 to the power infinity indeterminate form. So like we are going to use this concept. Like actually what 1 to the power infinity you should write in e power, and the power is there, no, gx should be in multiplication and subtract 1 from the base. Clear? Right? So that's what I did. This one I wrote in multiplication, I subtracted 1 from the base. This entire thing or this entire operation we must do in exponent e power. So I wrote e power L is the limit value, that is e to the power lambda. So like in right hand limit, what I thought is I can use 0 by 0 form. Like forgot about this. Tan 4x is there, no? There is like multiply divide by 4x. Here also multiply divide by 6x. There 0 by 0. I thought I can use it. But like here x is not approaching 0. So I cannot do that. Then what I did, I used L'Hospital rule. What L'Hospital rule says, you can take the limit in exponent, differentiate numerator and denominator separately as many times as you want to eliminate the indeterminate form. That's what it says. Now, once I differentiated, I got, you can substitute now, no indeterminate form at all. So like I got the limit value here, that is e to the power 2 by 3. Now using the definition of continuity, e power lambda must be equals e power 2 by 3, that must be equals to mu. Now we are substituting in this, lambda is 2 by 3, mu is e to the power 2 by 3. Notice that e power lambda and mu must be same. So mu power 6 and e to the power 6 lambda both will be same, will get cancelled and remaining is 10 over here. Any other doubts? Anybody? Any doubts?
Sir,
One moment. Is somebody asking here from online?
sir, in that e power tan 4x by tan 6s, I think we can also use that method, sir. The
No,
method that you
even I thought of using if I
because
multiply,
tan 4x will go to 0, sir.
but like 4x will not go to 0, no dear. At pi by 2, 4x is not 0.
Okay, sir.
Hmm. Right? Ah. Ah. L'Hospital rule says, please stay quiet. If we have 0 by 0 or infinity by infinity indeterminate form, there we can differentiate numerator and denominator separately. No, no, limit you can take in e power. That is not a problem. Anything else? See, like hereafter, I'm not going to tolerate who's disturbing my class. I'll throw you out of my class. Go out wherever you want. I won't mind. But don't make noise in my class. Any doubts? Anybody writing this part of the solution? Please write. No one is writing. Can I scroll up? What about this part of the solution? Anybody writing this part? Yes, no, please. If no answer, I'll scroll up. Writing? Right. That's all. Easier problems are done. Maybe if you want some problems like this, what I can say is maybe one moment. Problem 71 and problem 72 are problems on continuity concept. They have mentioned it is continuous, and from there we need to find some parameters which is not given in the problem. Clear? 71 can 71 and 72 you can try at home. You want same kind. So can I scroll up? Are we done? So like maybe this one is slightly easier in comparison to the remaining problems. That is problem 57 of page 59. So before doing this problem, let's say right. So we have a continuous function f of x that is continuous in R, right? So like what we can write in the continuity problems, they will use greatest integer, fractional part, modulus as wherever they want. Right? For that we should know how to break greatest integer, how to break modulus well. Right? What I can say here, I can say greatest integer of f of x, maybe let us call this one as g of x is equals greatest integer of f of x will be discontinuous for all f of x belongs to set, or for all whenever f of x is equals to integer. See, this might fail in some cases. So, like, benefit we should give like whenever f of x will be equals to integer, please do check that point once. Clear? So, like, second thing again, if I have g of x is equals to fractional part of f of x. So, fractional part of f of x also we can write same statement. Third one, these things we wrote under the assumption function f of x is continuous in R. Then greatest integer of f of x might be discontinuous whenever f of x is equals to z, right? So like again in fractional part also in least integer also you can add, but in case of modulus it will be continuous everywhere. Am I clear? Any doubts in this? Anybody? Right? So maybe like this one we will see in algebra of uh, continuity only, maybe next class, but like in this problem we will use that. Page number 57, sorry, 59, problem number 57. So in this problem number 57, if you notice, they have given f of x is equals to greatest integer of x by 2 into x, outside we have. Right, when it is there in multiplication or division, that we cannot take outside of greatest integer. Right. Hmm. See, if they didn't give this interval, then we have infinitely many discontinuous points. Since they have given this interval, we can count them finitely many only. See, like in continuity, we will also tell about continuity and discontinuity by drawing the graph. If we can, we will draw the graph and we will see whenever the graph is breaking, at that point, the function is discontinuous. Clear? So, how many breaks are there? That many discontinuous points. We know how to, maybe we can draw greatest integer x by 2 graph, but in x it is there in multiplication. That is slightly trickier, right? So now what I can see here, greatest integer of x by 2. If I see only x by 2, that is continuous everywhere. Since it is there inside greatest integer, what I can write here is greatest integer of x by 2 will be discontinuous whenever x by 2 is equals to integer. Clear? How many integers I have in the interval? In the given interval, for x it is minus 10 to plus 10, right? So for x by 2 it is minus 5 to plus 5. So the integers, if you count, it is starting from minus 4 to plus 4. There are 9 integers. If you are thinking the answer is 9, there is one exception in this case. That exception we are having because there is x in multiplication. Clear? See, like when x is approaching 0, at that point, the presence of x will make the function f of x as continuous. That we will see now. Right? This one everybody understood. Any doubts in this? Right? So like now, greatest integer of x by 2 will be a discontinuous whenever x by 2 is equals to integer. Right? So in the given interval, minus 10 less than x less than 10, minus 5 less than x by 2 is less than 5. Right? How many integers are there? X by 2 is equals to integer. This implies we have x belongs to minus 8, minus 6, minus 4, minus 2, 0, 2, 4, 6, 8. These are all points of like doubt is there at this points. Clear? So like now, always remember when there is something in multiplication, one might be discontinuous, another is continuous, and the continuous function having a root at that point, in that case, the overall becomes continuous. Right? You have two functions, f and g in multiplication. G is clearly discontinuous at a, but f is continuous and f of a is equals to 0, then f into g will be continuous at the given point x is equals to a. You understood this statement, right? So like now, notice that at x is equals to 0, I am checking the continuity, limit x approaches 0 minus, we have x into greatest integer of x by 2. As I mentioned earlier, for greatest integer, I will take some 0 minus na minus 0.1 or something. The moment I put minus 0.1, what I'll get? I'll get minus 1. So this is 0 into minus 1, which will be equals to 0. You be understood this one? Any doubt in this? Anybody? So like now, right hand limit will be limit x approaches 0 plus x into greatest integer of x by 2. So now you can take 0.1. This will be 0 into 0 I'll get. Now this is also 0. Notice that function value at 0. How much is f of 0? F of 0 is also 0. So f of 0 is also 0. This implies f of x is equals x into greatest integer x by 2 is continuous at x is equals to 0. Right? Now the points of discontinuity therefore minus 8 minus 6 minus 4 minus 2. Yes, please. Hmm. Yes. No, like listen to me carefully. That one I am using for greatest integer alone. In the left neighborhood of 0, the greatest integer value I want to use. For that, maybe you say a small thing I will use minus 0.1 for greatest integer, not for x. When greatest integer is there, fractional part is there in that case, not for normal x. Anything else? Please copy this one. Any doubts in this? Anybody? Any doubts? Okay. Anybody writing this part? One more time. Okay. They have given a function, something like this. If you want, you can write. I'll make you write in algebra of continuity. Always remember when there are two functions in multiplication f and g, right? See, f is continuous at a and f of a is 0. G may be continuous, may not be continuous. The product between f and g will be always continuous, right? So that's what we have showed here. Now what I did, only greatest integer of x by 2 can be discontinuous. X cannot be continuous for any real, x cannot be discontinuous for any real number, right? So now x by 2 we wrote will be discontinuous whenever x by 2 is integer. I found the range of x by 2, that is minus 5 to plus 5. There are 8 different integers are there. When x by 2 will be integer, x by 2 will be integer when x is even. That's what I wrote. X by 2 is integer implies that x is equals to minus 8, minus 6, minus 4 and so on going till 8. So now at 0 I have checked because using that one at 0 limit x approaches 0 minus x into greatest integer of x by 2 we will get as 0. Right? The 0 is there no? Finite value into 0 you will get 0. Now again this is 0 and this is 0 you will get 0. Overall f of 0 is also 0. Function is continuous at 0, right? If function is continuous, now 0 is not a discontinuity point, so that's why the points of discontinuity are minus 8 till 8 excluding 0. Clear? 8 points are there. Any doubts? So anybody writing this part of the slide? No one. Can I scroll up? Somebody writing? What about the remaining one? Some nice problems are there. Uh, 63, similar kind of problem. About discontinuity only they are asking, but not as simple as this one. Remaining, I think differentiability also we should know, then only we can solve them. What is break time actually? 10 or 950? 950, yeah. If it is 10, we can see continuity also. Okay. So then you can go for break if you want. I'll check with sir once. If sir is here, sir will take, or else I should only continue. Right. So please go for break. I'll do check with sir once.